Okay, good morning. So I just wanted to, we have a interesting program today, a number of speakers talking about their experience with EHR data. So I just want to set this off by just giving a very brief introduction to our journey in terms of how we got here. Healthcare is awash with data. And so in many ways, you can think of big data in healthcare as elephants are to blind men, right? So AI in general and machine learning in particular, if it is properly applied, can help the blind man make sense of this massive amount of data. And this is also true in not just clinical data, but more generally in terms of data from the social and built environment, and sort of more holistic idea of social determinants of health and many other factors. And AI and machine learning, again, if properly applied, can help make sense of this data. And there's already a fair amount of applications of AI in medicine. Here's something that I took from New York Times in 2019. And this was an application of AI in radiology. And it claimed that an AI system was competitive in terms of being able to do the diagnosis in radiology with relative to a radiologist, right? And there are plenty of applications of AI in medicine. Here's just a list of potential areas that one could work in. And almost any area in medicine where there is large amounts of data, you can potentially use machine learning to be able to get value out of that data. So here's something that I took from a Nature Medicine article in 2022 by Eric Topol, who has written a great deal about the role of AI in medicine. And he sort of lays out the areas that have been reasonably well developed. And for example, medical image interpretation is an area where there's a fair amount of development in AI. Whereas when it comes to electronic health records and other types of data, we still have a lot of opportunities, and there's a lot of room for further development. So current state of AI, if you think about it, it's AI has been in medicine from the very early days. And in fact, the first papers on this appeared back in 1950s or 1960s. And there was a great deal of optimism. And then all of that optimism sort of went away because the problems that people were trying to solve were just too hard. But then so we went through a couple of AI winters, but then recently AI has had a fair amount of success. And this is largely due to the availability of data and computing. And of course, there's methodological advances as well, but without large data sets, AI would not be able to do anything in biomedical sciences. So in these high stakes applications, we need not necessarily AI to automate what physicians do, but to augment and extend human expertise and abilities. And there are many dimensions of AI that probably did not receive a lot of attention early on. For example, explainability of AI systems and handling bias in data. And then there's a long list of potential pitfalls that I won't get into here. But there's a fair amount of progress being made on all of this. Right, so there is, and today we primarily focus on a couple of aspects of what is needed to make the best out of AI in the biomedical research arena. And one is infrastructure for data access and use policy compliant analysis. So without access to large data sets, we cannot do anything with machine learning. And then the second thing that's really critical is interdisciplinary collaborations. There are many other things that we could talk about, but I won't. We won't have time today. Okay, so I'll very briefly introduce how we got here, right? So the problem is that realizing the promise and potential of this big data, including electronic health records data, in biomedical and health research is limited by the lack of a means to seamlessly and securely access and analyze health data. So we, for several years, we've been working on a solution to this problem, which is to create this infrastructure for access to this data. And so this is a joint effort of Penn State CTSI, and I will thank some key individuals at the end of this presentation, and in collaboration with a few other partners. And so the goal of this effort was to get the Penn State electronic health records data ready for data-intensive research. By that, I mean this data has to be standardized in some form so that analysis that we do on this data here at Penn State is comparable and compatible with similar analysis that could be carried out at other sites, and so provide some basic AI ML enabled research tools, and get Penn State EHR data ready for multi-site EHR-based studies, because no individual site has all of the data that you would need to draw reliable conclusions from these kinds of data sets, particularly when you have very small patient populations for certain conditions. But if you can pull data from multiple sites, then you can do much more with this data. And then in order to really use this data, you need infrastructure. So these data sets are large. So it's not something that you can always download on your laptop and do something. And even if you could download on your laptop, there may be reasons why you don't want to be able to do that, right? Because of the sensitive nature of this data. And so, those are our goals. And so we will have examples of 2 ways to do this here at Penn State. One is based on an initiative that we leveraged called the Odyssey, which is an NIH-funded initiative led by Columbia, which aimed to create a standardized way of representing electronic health records data. So there is a data standard called OMOP. And so if you, the model is that each site retains its own data, and the data is organized in a common data model. And then as long as you have data in that form, you can analyze it at your own site, but you can also participate in multi-site studies. So I won't get into the details of this OMOP common data model, but there are now individuals here at Penn State who have used it to do machine learning based research with electronic health records data. So we have an implementation of this common data model. Then so this is sort of the idea here. The current state of it is that we have the OMOP based EHR repository, data repository. This is not the operational EHR system. It's a research version of this data set. And in the future, we hope to be able to integrate other types of data that is currently not in the EHR to be able to do more sophisticated analysis with this data. So, and this, as I mentioned, Odyssey is a multi-university, collaboration. So there's a whole consortium that is that has institutions that are members of Odyssey, which has now over 200 institutions around the world. So in principle, if some investigator at Penn State wants to do a multi-site study, you can work with any subset of these institutions, right, that have investigators that are interested in similar questions. And so, so you can basically agree on a study, question and research protocol, replicate analysis across the participating sites, and aggregate the results. A second system that we have is a license which we have through Translational, which gives us access to de-identified EMR and claims data from aggregated data from multiple hospital systems that have agreement with Translational. Now the Odyssey data versus Translational have pros and cons. In the case of Odyssey data, each site controls its data, so there's a lot more you can do with that data. Whereas in Translational, you get aggregated data, you don't necessarily know where that data is from. And but nevertheless, you can get very large data sets very quickly through Translational. So you decide on a study, identify a cohort, and then obtain the data and analyze it. Right? This data set includes more than 400 million patients, EHR and claims. Cohort is de-identified because the data set is large. Again, you need high performance computing and the software stack to be able to analyze this data. So there's a lot of ongoing work on the methods, which I won't get into. So EHR data is much more complex, particularly if you want to look at it as longitudinal data. There is work to be done beyond existing methods, and that's ongoing. And there's work to be done in terms of establishing cause and effect relationships from EHR data and integrating EHR data with other types of data. So what we next have is 3 excellent presentations that give you some examples of the work that's already being done using data here at Penn State, just to stimulate people's thinking about what could be done and get more people involved in this type of research. I would like to end by thanking CTSI leadership, Jen Krishnowski and Larry Sinaway, for sort of buying into this vision, right? So we didn't always have this infrastructure here at Penn State and making it possible to pursue this. And then Avnish, who many of you know, the CTSI Informatics project manager, has been instrumental in a lot of this, getting this infrastructure up and running. And of course, ICDS and CTSI staff who have helped put together today's event. Thank you. And then I will hand this over to the next presentation.